Our topic for today is about the mechanical system. So this is the course packet 2 that's included in learning module 2. So in course packet 1, as a review, it is assumed that you already are familiar with the three different mathematical models, which includes the ODE or differential equations. We also have the transfer function and the steady state model. And for us to be able to work hand in hand with these three mathematical models, we would need to be skilled in Laplace and inverse Laplace transforms. It is also assumed that you already know the basics of the control system. Okay, that includes the basic model, which consists of the input, output, and the control system itself. Okay, so we can now jump right into mechanical system. So we have two kinds of mechanical systems. So the first one is translational, and we also have rotational. Now, when we talk about mechanical systems, we are dealing here with force. So if in electronics and electrical, we deal with current, voltage, in mechanical system, we deal with force. So what's the difference between the two mechanical systems? So for translational system, the force moves about a straight line. Whereas for rotational, it is a system wherein the force moves about an axis. Okay, let's change this. It should be moves along a straight line. So for rotational, it's the force moves about an axis. So we're going to deal first with the translational mechanical system. So for translational mechanical system, we have three basic elements. We have the mass, dashpot, or we also call this as damper, and the spring. So what is mass? So sabi, mass is a function of acceleration. So let's try to draw a system that involves mass. Okay, so this is the mass. This is a reference point or a steady reference point. So sabi nga, with mechanical system, we deal with force. So for this one, we have an external force here. Okay. And we also have the x, which is displacement. Displacement meaning yung movement ng object mismo. So this is the object. And mass is denoted by this triangle. Okay. So sabi, note that if force is applied, and this is applicable to all the basic elements of translational mechanical system. Note that if a force is applied, an opposing force exists. Okay, so if we apply here a force, external force, we can assume, or it is given that we have here an opposing force. So you can see an opposing force has an opposing direction. So this one is going towards the right, and this one is going towards the left. So we call this as EFM for mass, and this is the opposing force, or it is also the force due to mass. Okay. So since we mentioned already that mass is a function of acceleration, wherein acceleration is equal to dx squared over dt squared. Okay, basic physics, we can get the formula for this force as, so again, Fm, or this force due to mass, is a function of acceleration. We can assume that this is the formula: mass times the acceleration. So mass, let's substitute this to this, dx squared over dt squared. So this is the formula for mass. So therefore, according to Newton's law, the force here, the external force, is equal to the force due to mass. Okay, so that we can attain equilibrium. And since this is equal to this formula, we can assume that this as well, the external force, is equal to md squared x over dt squared. Okay, next we have the dashpot. So if mass is a function of acceleration, dashpot is actually a function of velocity. Okay, so let's again draw the system for dashpot. So this is the symbol for a dashpot, and we have here again the reference point. So dashpot, it has the element of B, which is friction. So B is the denotation in physics for friction. So if we have here the force due to the friction, we can say that it is also equal to the external force here. External force, or we can also call it as applied force. Then let's not forget about the displacement here as well, which is x. Okay, so for dashpot, this is the first case wherein one side is attached to a reference. So the formula for this one is, again, the force due to friction is proportional to velocity. But ano ba yung formula for velocity? Velocity is equal to first derivative of displacement. Okay, so we can assume that FB is equal to BV. So this formula came from this proportionality. And then FB is equal to B. B is our coefficient, and we can replace V with dx over dt. So this is the formula for the force due to friction. Therefore, again, since F, or applied force, is equal to the opposing force FB, then F is also equal to B dx over, B dx over dt. So this is for case 1. Okay, case 1 is when one side of the dashpot is attached to a reference. What if the dashpot is not attached to any reference? So this is case 2. Okay, so ganyan lang siya, open lang siya. So Pag ganyan, magkakaroon tayo ng two displacements. So, displacement from both ends. Okay. Case number 2. This is if no side is attached to a reference. So, paano gagawin pag ganyan? So, FB, which is the force here, force due to friction, will be proportional to x1 minus x2. Okay. Instead of dx lang, kukunin natin yung difference na x1 and x2. So, given that F is equal to FB is equal to B dx over dt, this is for case 1 kanina. So, we will use this as reference to derive the formula for case 2 as well. Therefore, for case 2, F is equal to FB is equal to B first derivative of x1 minus x2 over dt. So, this is now the formula for case 2. Okay, so the only difference is that we replaced this x with x1 minus x2. So that's for dash pot. Next, and the last one is spring. So, if mass is a function of acceleration and dash pot is a function of velocity, spring is a function of displacement. So, displacement, yun lang yung x. So, paunti ng paunti. So, for mass, we have acceleration. For dash pot B, we have velocity. For spring or K, elasticity, we have x. So, ang characteristic ng spring is that it has elasticity. And we use letter K for elasticity. So, in essence, ang elasticity means that a spring stores potential energy in itself. Okay, so remember that, basic physics. So, we can draw spring as this. It looks like an inductor. So, this is the first case, again, is that it is attached to a reference. So, this is case 1. And, gaya nung sa mga kanina, we also have an external force and the opposing force, which is due to elasticity. So, we denote it as Fk. We also have here, the displacement x. Okay. So, sabi, Fk or force due to elasticity is proportional to displacement x. Therefore, Fk is equal to K, yun yung factor, elasticity factor times x. So, again, F is equal to Fk, therefore, F is also equal to Kx. So, this is the formula for case 1. Now, we can also have case 2 for spring. So, ang case 2 is if it's not attached to a reference. So, both ends are free. Okay. So, we have here again the force and we have x1, we have x2. So, in essence, instead of x, this one is proportional to x1 minus x2. So, the difference between the two displacements. Therefore, F is equal to Fk is equal to the factor K, elasticity, times, instead of x dito, we will replace it by x1 minus x2. So, this is now the formula for spring case 2.